Today we're doing an AP Physics 1 multiple choice question in Unit 7, so let's get right into it. A student conducts an experiment in which a disk may freely rotate around its center in the absence of frictional forces. The student collects the necessary data to construct a graph of the rod's angular momentum as a function of time as shown. The student makes the following claim. The graph shows that the magnitude of angular acceleration of the disk decreases as time increases. Which of the following statements is correct about the student's evaluation of the data from the graph? Justify your selection. So before I look at the graph and really start getting into it, I sort of let my eyes glaze over the different answer choices, and I can automatically see that the student is correct, the student is correct, the student is incorrect, incorrect. So it wants us to determine whether the student is right, whether what the student is claiming is correct. So the student is claiming that the magnitude of the angular acceleration, also known as alpha, and they're saying the magnitude, decreases as time increases. So the magnitude is going to decrease as time increases. So that's what the student is claiming. And I mean, we can try and figure out whether the student is correct or incorrect, but let's look at our graph here, what we really have, because this figure is probably important. So we see that's angular momentum versus time. So let's see, is there any equation that we know that relates angular momentum and time? So there is one, and it's on your equation sheet, and angular momentum is, the symbol is also L for angular momentum, and we have equals to torque delta T. So we have delta L and delta T over here. We know that we wanted that because that's what our graph gives us. If we look at this here though, what is our slope giving us on this graph? So we know the slope is delta Y over delta X. That's the formula for a slope. We can see on our y-axis, our delta Y is going to be angular momentum, also known as delta L. And on our x, we have time, delta T. So that's going to be our slope. So at this point, you might be noticing something, that we have delta L and delta T over here. All we need to do to get to our slope is divide both sides by delta T. So in that case, we would get delta L over delta T is equal to the torque that we still have. That's a symbol for torque. So once you divide delta T on both sides, you get this. So now we know that our torque is equal to the slope. So that's very important. The torque is the slope. So let's look back at our answer choices here. Let's look at part A. The student is correct, we don't know yet, because the angular momentum of the disk decreases as time increases. We can see that the second portion is correct. The angular momentum does decrease as time increases. So that you got that right, but is the student correct? We don't know yet. Let's look at the next one. Because the slope of best fit curve of the graph remains constant. So the student is correct. That's true, the slope of the best fit curve does remain constant. So that means that the torque is a constant value. So that's also something to know. We know that that's true because this line is linear, so we know that the slope is constant. It's basically linear. So we know that that slope is constant, and since the slope is constant, our torque is therefore constant. So that is true, but we don't know if the student is correct yet. Let's look at part C. The student is incorrect because the graph shows that the net torque exerted on the disk is constant as time increases. So that's true. The net torque exerted on the disk is constant as time increases. That's a true statement too. So all of these have, the second part is true, but this one, the student is incorrect. Let's think about this here. So we have torque and we have alpha. Is there any other equations that we know that relates torque and alpha? Hopefully, this is on your equation sheet too. You remember the equation, I don't know why that all changed, that T torque is equal to I alpha. And both of these equations I directly took from the AP Physics 1 formula sheet. So that's going to be with you on the exam. So look at that. as torque increases, alpha is also going to increase proportionally because these both are raised to the first power. So since those are both raised to the first power, I know that torque is directly proportional to, it's a little confusing because the directly proportional to sign kind of looks like an alpha, but torque is directly proportional. That says directly proportional to alpha, okay? Let's say this was a squared. We would have torque is directly proportional to a squared, but torque is directly proportional to alpha. At this point, this doesn't matter because we're not changing it. So if torque is directly proportional to alpha, where alpha is our angular acceleration, and we know that torque is constant, that also means that alpha needs to be constant since they're directly proportional. These both are going to be constant, okay? Since they're directly proportional. But wait, the student is saying that the angular acceleration is going to decrease. That's not what we said. We said the angular acceleration is constant. It's not decreasing, it's constant. So we know that the student is going to be incorrect because they're saying that it decreases when really it remains constant. So with that said, A and B are out. C looks like a great answer. D is incorrect. The graph does not contain enough information. Obviously it contains enough information. We just found it. So in this part, C is going to be your correct answer. And that's because we used conservation of the linear momentum. We used the linear momentum, changed the linear momentum equation. We found that slope. We found that the slope was constant because it's linear. So we know that torque is constant, and we know torque is equal to the rotational inertia times the angular acceleration. Since torque is constant, angular acceleration is also constant, and that directly contradicts what the student is claiming. So therefore, C is the correct answer. Hopefully this helps, and comment if you have any questions.